All right. I think that's my cue now.
Yes.
So once again, thank you everyone for the opportunity for SPRI to come here and talk about best practices from the roofing perspective when it comes to this interaction between the roofing systems and uh, PV photovoltaic installations when they're put on the roofing space. Um, as someone as was mentioned, I'm serve as the technical director for SPRI. I've been in the roofing industry for 20 years. And my entire career has been technically focused. I've been in the manufacturing sector, consulting sector, and now I work for trade associations. And I've done all sorts of activities from field inspections to product evaluation, testing, standards development, and regulatory advocacy. I do have a mechanical engineering degree from University of Miami, and I participated on a couple of standards, three standard consensus bodies with SEIA, just continuing that effort to collaborate where we can, making sure that we had some concerns of the roofing industry captured in those documents. And I think that was a successful collaboration. I look forward to seeing those final publication dates for all those standards. So today we're going to do a brief introduction of who SPRI is, what we do, and then we'll get into the meat of the presentation, talking about the background on rooftop equipment attachment, of which a subset is the PV systems that get put on roofs, including highlighting some things about a standard UL 2703A. We're going to talk about some solar mounting products that are approved by manufacturers of roof systems and some best practices for the installation of PV arrays on the roof, including protecting the roof membranes during those installs, some flashing detail concerns, and compatibility with existing roof coverings. And then we'll turn our eyes to performance concerns and then wrap up our presentation real quick. So who is SPRI? SPRI, the acronym stands for the Single Ply Roofing Industry. We've been an association since 1982, so we are approaching our 50th anniversary here in 2031. But we have 60 plus members, and those members range from manufacturers of roofing components, the membrane, the fasteners, the glues, to the raw material suppliers that help us manufacture those components to the accessories that go into those systems. So it could be someone that just makes flashing detail components or other ancillary items, walkway pads, some of the anchor systems that we're going to talk about later in the presentation. And we also have testing labs where our products are evaluated, as well as design stakeholders. We do have a couple consultants in our membership. We actually have one consultant that serves as a, a board member at large. So we do try to have that broad voice of the industry, not just the manufacturing side, but a broad perspective from our membership. Primarily, we're known for our standards. We curate a library of standards. We also try to contribute technical articles, general technical guidelines for design, and other information around roof maintenance repairs and other technical items that arise. But right now, we're primarily known for our standards. We also educate through our white papers and presentations, webinars like this one, articles targeted toward contractors, design stakeholders, building owners, and we advocate multiple arenas on behalf of the thermoplastic, thermoset, and modified bituminous roofing systems. And those are really the main three categories of single ply roofing that's out in the marketplace. Speaking of our standards, I wanted to try to make this as easy as possible. So if you scan that QR code that's on your screen right now, that'll take you to our landing page for our standards. All of our standards are free of charge to download. We also have all of our historical standards. So even though we have the most up-to-date versions of our standards, because various editions are referenced in different codes and we know how the adoption rate is varied across the country, we do have all the historical versions of our standards available on our landing page as well. So that QR code will take you directly to our entire library. Right now we have 16 today. We are working on a new standard, and we do have a few of these that we are currently working on revising and updating. All of our standards go through the ANSI process. We do the consensus process through ANSI, and so we're really proud of our library and as we continue to grow it. Of note for this audience, we wanted to highlight a few standards in particular. The first is WD1. It's a wind design standard for roof assemblies. This QR code will take you specifically to this standard. So again, trying to make it easy for everybody that's listening today and maybe watching the recording later. But this QR code will take you directly to our wind design standard. It's primarily around looking at vegetative roof systems you see on that title page there, but we wanted to have that resource. It's trying to fill in that gray area. You guys talked about gray area earlier in the comments, that gray area between what the standards are, especially when you're talking about ASC 7 and the code and everything, and the reality of trying to figure out how to determine what you need to be looking for in a product evaluation report, and making sure we're pairing the right products and installing the right products in an assembly. After that, we have VF1, which is our external fire design standard for vegetative roofs. Um, Obviously, when fire is a big deal when it comes to roofs, we do a lot of testing around roofs. There's a lot of code language around fire classification, and so anytime you're adding components above the roof, um, one of the to break it down simply, a lot of times that gets classified as more fuel, right? Or is that more fuel? And so this standard right here is just outlining some things to be considered, and that should be um, confirmed when designing a vegetative system for external fire ratings. Um, the roof's becoming a dynamic place. It's not just solar arrays going on roofs, it's vegetative roofs. And honestly, trying to put my foresight hat on here, I think we're going to see like mixed use roof spaces in the next decade or so, where it's going to have all these different components interacting on a singular roof space. So just something of note for you guys to have in your pocket. Next is GT1. It's a test standard for gutter systems. This bore out from a lot of windstorm, post-storm investigations of hurricanes and similar storms. We found that we were having a lot of issues with edge securement, especially if a gutter was being used as that edge securement. So it was kind of pulling double duty, both as the gutter and traversing water off of the roof, to also serving as that edge securement. And so one of the things we've developed here is a test standard to evaluate those different gutter profiles and their anchoring spacing, the anchoring sizes, the materials they're made out of, thicknesses, geometries, and whatnot. And so this standard has really made a lot of headway into addressing those issues we were seeing in post-storm investigations. And finally, ED1 is a design standard for edge systems and low slope roofs. So uh, kind of broader view than gutters. It's really trying to determine what are the pressures and what are the design thresholds of the components in the roof. And so these four standards we want to highlight just to give you an idea that, we're not just worried about the products on the roof. We are wanting to make sure that they're being installed correctly and that they're positioned to withstand the expected nature events that they're going to endure over their long life cycles. And so we just want to try to convey that, and we thought these were kind of the four most likely to be of interest to this audience today as we start talking about rooftop equipment attachment. Uh, Speaking of segue, we're going to get into that. So the first thing I want to provide a little historical context. The SPRI, we had a task force, a SPRI task force, and Curtis Lipscomb, who's an RRC and RRO, which is a registered roof consultant, registered roof observer. Those are accreditations from IBEC, the International Institute of Building Envelope Consultants. He worked with us to author a white paper on rooftop equipment attachment. Once again, I've provided a QR code if you want to pop that up in a tab for later reference. And basically, we outlined at the time what were the code parameters and the questions that people were commonly wanting to understand about rooftop equipment. And it's not just PV, it's anything that's on a roof. Most typically on the roof, you see HVAC installations, you see a lot of utility lines being run across the rooftop. Sometimes you have these weather stations or cell phone relays that get installed, antennas, satellite dishes. So, solar arrays are definitely not the first visitor to the roof or the first thing to be installed on a roof or utilize the roof space. And so secure attachment of all of those things have been of the utmost worry, concern in our eyes, and we wanted to make sure we were addressing it. So we provide this white paper as a resource, and it's primarily because we want to avoid seeing things like this. This is a photo from a Rokawi wind investigation report after a hurricane. Improperly attached rooftop equipment can become dislodged in wind events, and now even more recently, we're starting to see concerns around seismic events, and that's really not good for the roof because aside from the equipment itself becoming dislodged and possibly damaged, it moving on the roof can lead to damage to the roof, which leads to further damage inside the structure. especially when we end up hearing about membranes being torn by either panels or entire pieces of equipment, kind of doing a somersault act in a windstorm. And those tears are going to allow water intrusion. It might not be water into the building itself, but it allows it into the roofing system, and that can be just as detrimental. Dislodged equipment can become windborne debris as well. And so now we're worried about, I think everybody saw a picture after Hurricane Katrina of those high rises with shattered fenestration, glazed windows being shattered. That's really what that was, is uh, things from a roof becoming airborne in a storm and basically becoming projectiles against other components that are being exposed to the same storm. Some other resources in a context sense we wanted to provide. FEMA and IBHS also have guidelines around rooftop equipment attachment. So we provide QR codes for both of those. I will warn everyone with these two documents, the rooftop equipment is part of a larger document. I couldn't make the QR code go to the specific sections within those documents, so there is a little searching within it to find the specific information about rooftop equipment attachment. But we did want to provide both of these resources to everyone, just for further a broader understanding and just having more resources that weren't just SPRI generated resources. We want to convey that, this is an item concern, and when there's resources available, we want to point people to where they're at. So these two documents are definitely worthy of consideration and reference as you're looking into this topic. Code background, we're going to talk about the current code, but a little history. 2012 was actually the first edition of the code where there was kind of any code language around setbacks or pathways around PV. And of course, that impacts roof when you're talking about setbacks, because usually those become the walkway paths on the roof. And a lot of times with those roof paths, we want an additional sacrificial piece or intentionally designed walkway pad installed over the roof system. And so those setbacks and pathways actually became locations where manufacturers started to really advocate for the placement of walkway pads. And that gave us an easy place to say that's where they should be located. But the current code in the mechanical code, in Chapter 3, Section 301.15, mechanical equipment, appliances, and supports that are exposed to wind should be designed and installed to resist the wind pressures determined in the IBC. And so this is kind of that first pointer. Appliances and support mechanical equipment, a lot of times I think gray areas aside, this is where PV equipment gets kind of pulled into the building code. If you're not even talking about the Chapter 31 references that we are getting ready to discuss. Um, Speaking of International Building Code 2024, the Chapter 31, there is a wind resistance uh, terminology there or section there. Rooftop mounted PV system and solar thermal collectors shall be designed in accordance with Section 1609. And so, since we're talking about 1609, this is where 1609 comes into play, and this is where it starts talking about roofs. In subsection 6 of that, the roof deck shall be designed to withstand the wind pressures determined in accordance with ACE 7. Roof deck's an important term. It's actually the structural component at the bottom of a roof assembly. It's if it's not serving as the roof itself, which can be the case in some metal systems or some composite component systems, everything else typically is installed on top of the roof deck. And so it's really the structural component that is a vital importance when it comes to that, because everything that's installed on top of that transfers any loading it takes directly into the deck, and then the deck is what transfers that load into other components of the main structure. And to show what I mean by that, the next one, roof coverings, it just says roof coverings shall comply with the previous subsection. So even the code is saying, yeah, the roof deck is where you need to do your determinations, your calculations, and whatnot. And basically all of the stuff in Chapter 16 ends up pointing to ASCE 7. So the latest edition of ASCE 7 is the 22 edition. Uh, the general wind requirements are in Chapter 26 of this document, but roofing systems, aside from the deck, are really considered components and cladding. And so we look a lot into Chapter 30 on components and cladding. Chapter 29 is obviously building appurtenances and other structures. So that's where your PV systems get into. And of course, with this edition of the code, they pulled a lot of language that was in commentary for previous editions of ASC 7 and pulled it into what is now Chapter 32 around tornadic loading. And so it makes clear and now it makes required um, determinations whether tornado loads need to be part of the assessment when calculating wind uplift when we're working with PV systems or other components in cladding like the roofing system. Some other additions of the code have expanded the requirements of seismic loading. ASC 7 also has the seismic calculations. Roofing doesn't really get into seismic stuff, but with PV systems, we did want to highlight that given the audience we're talking to, that this would still be the same reference you would go to. UL 2703A is a really recent standard development. It's a outline of investigation for flashing devices and rooftop mounted photovoltaics. It's a standard. It covers a broad range of materials, polymeric and metallic flashing materials, and it tests for it's an omnibus really standard of test, testing for multiple things, wind-driven rain on various slopes of roof, water penetration, impact, elongation, tensile. Um, when this first came out, SPRI was presented an opportunity to kind of review it and input it. We did have some concerns around the standard, some shortcomings we felt from our general membership. Some things were regarding the xenon arc testing, lacking clear defined exposure for the xenon arc and the fluorescent UV test. It lists hours without having a specific setting for the irradiance. These are really nitpicky things, but it's things that are similar to what roofing materials are assessed with and against. And so it was just one of those things that if the roofing material, these things are being installed too, since it is flashing. Um, we feel like these components should also have to at least have a similar threshold of testing as to the components that they're interacting with and being installed to work with. So, aside from that long list, this has been a great standard to be included in the code. We're supportive of UL, and we want to see future reiterations and updates and revisions with the standard moving forward. But I think this is probably one of the first examples of collaborative efforts when it comes to a roofing material or a material meant to interact with roofing materials in the PV industry. Moving on to solar mounting products approved by roof covering manufacturers. Traditionally, there are three methods of attachments. I think we all know them, but just to make sure they're ballasted, which means that we're using the dead load of some material to hold it in place. There's adhered attachment where we're creating some kind of bond between the PV module and the top surface of the roof. And there's mechanical attachment, which we're going to get in a little more depth. It's hard to simplify specifically, but visually, this is kind of the best representation of ballast. Uh, you have your PV panels, and in between or even underneath, depending on the geometry of the support structure, you have a weighted component, whether it's blocks or I've seen sand, I've seen rock. Roofs have used ballast for a long time. We use stone. We get really particular when some people call it rock or gravel. It's a specific stone. It has a standard, and just like for you guys, I'm sure there are some specifications around ballast. Um, and it's really easy to install, right? You're not penetrating the roof. You might have to install some sacrificial sheets underneath where the ballast locations are. But it relies on the weight of those ballast materials to create friction and a resistance so that the structures themselves don't move anywhere on the roof other than when they've been placed, and also to resist any uplift from wind events that it experiences. The issue there is that when these first came out, they were also relying somewhat on the weight of the structure. And as you all know, I believe the equipment itself has become lighter. And so now it's become to use ballast to get the same amount of weight, you're having to actually install more ballast material to keep the same kind of size panel and structures in place. The issues with that is that when you start to increase the ballast, it instead of it being over a area, you're increasing the weight over that area, and now we're getting into the compressive strength of the components installed within the roofing materials. Um, other the other thing is too is while they are designed to withstand windstorms, we understand statistically we're working with models and stuff. It doesn't mean that you won't have a highly localized event, and now you're dealing with an issue where something that was designed for a statistical event is now dealing with a singular event, and you're going to get movement and stuff in those kind of instances. And so, um, it's not a strike against this in any means to say these aren't good systems. It's just one of those things to be aware of and kind of want to make sure that there is a factor of safety included in the determination when we're working on these types of systems. Unhered involves that direct attachment of components to the roofing covering material. It results in a direct load pass. So basically, any loading that these materials install directly to the top of the roof, they're going to transfer that load into the roof covering, and then the roof covering is going to pass that on to its load path down to the roof deck. Um, some other things to be concerned about when we're talking about adhered is component compatibility. A lot of times, uh, roofing systems are really controlled by one manufacturer usually, and so we're from a manufacturer's perspective, we're testing all the materials within that to make sure they're compatible with each other. So we know the glues and adhesives work with the backside of the membrane and the top of most of the substrates we're dealing with. When we start to work with other industries, we don't, because those industries are so broad and varied, we don't have the ability to be able to test every product out there. And so then it really becomes crucial to ensure that there's some kind of assessment, making sure whatever the adhesive being used, it is compatible with the membrane that it's being installed to. The other thing too is with adhesives is your open set time. One of the big things in roofing is that a lot of our adhesive products do have a cure time until they reach their full potential of resistance. Even in testing, we have a 28-day cure time. And so if you're using adhesive to install these types of components, you do have that concern of if you have a cure time with the products being used, what occurs during that cure time. If it's you need 28 days and you have an event happen on day 18, what's going to be the result of that event. Uh, the other thing too is that the maintenance of these, any exposed component of the adhesive, sometimes you have to worry about degradation over time, being exposed to UV and other environmental factors. And so now you have to ensure that there is a maintenance plan in place with these adhered systems uh, to make sure that you're not working toward a failure due to that degradation of exposure. Lastly, we do have mechanical attachment. This is probably the most prevalent and most commonly understood or seen attachment method. It involves putting a component that penetrates through the roof system and creates that load path directly to the roof deck. Um, and while that's beneficial from a structural and wind resistance standpoint of creating that direct load path, we've now penetrated the roof covering, and the roof's primary function is to keep the weather out. And so essentially, we've put a hole in a roof. And the big thing is about making sure we put the proper flashing in place after that. The hole is made and the components installed, making sure we're flashing to the roof system to make it weather resistant again. That involves coordination a lot of times because many times when we're doing these types of systems, the contractors and tradespeople that are installing the PV installation and the components aren't the same tradespeople that are doing the roof installation or doing the flashing installation. And I know there's some components that um, are working toward trying to alleviate that particular item, but there is some coordination that's needed between the trades of when the flashing can get started, when the penetrations have been made, those kind of things. Um, Another thing that's involved is attention to detail. I was an inspector about 18 years ago, and I was on a job, and it wasn't a PV job; it was a mechanical. But I watched a tradesperson make a hole, look at the hole, take his drill another hole right beside it, look at that hole, took out his tape measure and started measuring and walked away. I went over and where he had to cut two holes, it looked like a binocular. There was a purlin running right underneath those two holes. And so it's that attention to detail of like when you make a hole, make sure you're making a hole in the right spot kind of thing. So we don't have additional repairs to make. Because anytime we're having additional repairs, it's just creating more seams and more opportunities to compromise the roofing system. Um, which would be the last point. With that increased number of penetrations, the number of potential entry points becomes increased, again, from a mathematics perspective, you want to keep those as small as you can, understanding that we do appreciate that direct load path of this type of system. Uh, that takes us to talking about flashings. And on the screen here, I've got a few detailed examples of different various flashings uh, common in the marketplace. On the upper left is a unique component that basically it creates a mechanical attachment through the roofing system, and then there's a cover that gets installed to create that weather resistant barrier that I was talking about. In the lower right is another component that's actually made with membrane, roofing membrane. There's a couple of companies out there, I think, and a lot of manufacturers have partnered with those companies to make these types of components. And so essentially, there's a plate or some kind of mechanical attachment area underneath that membrane, and that membrane is adhered in one fashion or other. There's a few different technologies out there. And so that piece of membrane, you can fold it back, do your mechanical attachment to create your low path, let the membrane relax and fall over that, and then there's enough membrane that the roofing contractor could come in and do a roofing seam at the perimeter of that, basically creating that weather resistant seal again. And then you have your mechanical components protruding up to do the attachment of the components above the roof. The other three pictures are the more traditional details I saw in my career when I was in the field. The upper right is a fluid flashing detail. So essentially, it doesn't matter the geometry of the penetration, but the material is usually a liquid component with a reinforcement component. A layer of the fluid would go down with the reinforcement fabric, and then another layer of the fluid on top to encapsulate that fabric to create basically a bespoke flashing boot. It's a play on that center picture in the front, which is a prefabricated boot. These work really well for round penetrations. It's stepped to different diameters. So you cut the diameter, the more appropriate diameter for your penetration, uh, secure the membrane around the penetration, install the boot over those fasteners, and do the bond at the flat of the roof, and install a mastic at the top with a pipe clamp to secure that tight. Last, over on the lower left is what we call a pitch pan in the industry, in the roofing industry. That comes from built up days where we used to fill those with pitch. Now they're usually filled with some composite material or other fill material. But basically, it's a box that has compatible material, and that box creates a perimeter around the penetration. And then once it is installed, the cavity between the box and the penetration is filled with some kind of product, and is usually topped off with a component that has to be monitored and maintained over the life of the roof. The reason this is important is because, as we talked about earlier in the code, we have language in the roofing chapter, which is chapter 15 of the building code, around flashing. And this says 2018, the language has remained the same through 2024. Flashing shall be installed in such a manner so as to prevent water from entering the wall and roof through joints and copings, through moisture permeable materials at intersections with parapet walls and other penetrations through the roof plane. So it's one of those things that not only is it important specifically manufacturers because we want the roofs not leak, flashing is actually a code required component of a roofing system. The issue really comes into sealants, and I highlighted those two details there because the IBC doesn't have specific language around sealants. The closest I can pull language in is from another chapter a section in chapter 15, requirements for roof coverings, and it says roof coverings shall be applied in accordance with the applicable provisions of the section and manufacturer's installation instructions. And so basically these details that were provided by some of the members of our of SPRI, all those details earlier were from SPRI members. But I highlighted the areas where sealants would be involved with the pitch pan and the pipe boot detail. And so basically, the manufacturer's instructions would be that these would have to be maintained. And so essentially, because the manufacturers have that requirement, this code language pulls those instructions into the code and makes them a requirement. And Jeff was kind enough to provide me this picture here of a degraded kind of sealant. Uh, this makes me cringe as a former roof inspector because there's no pipe boot in this detail whatsoever, but it's clear that this sealant has degraded over time due to exposure. This would be the kind of thing that we would, even in a properly installed detail with the sealant in its place, this is the kind of thing that needs to be monitored and maintained over the life cycle of the roof. So now we want to get into best practices. First, perform a roof evaluation by a roofing professional before beginning an installation. And these are all examples of the different documents that need to be collected, created, or referenced during that evaluation. On the left is an example of a roof evaluation report, including pictures and doing a description of the state of the roof. Obviously, we have multiple codes that we probably need to double check and make sure we're in compliance with, which then reference standards. And so we need to pull in the necessary standards. And then finally, we have product data sheets and information sheets. So once we have that roof assessment, understand what the products are to make sure that we're getting compatibility with everything that is being considered to be installed. The next big thing is to develop a plan to minimize damage to the installed roof. We want to minimize the traffic on the roof. With this picture example, let's say the photovoltaic system in question wanted to be installed on just the north half of that big part of that building. It would be better to stage all that material on the northwest or northeast corner in those grassy areas so that the components can be loaded into the installation area rather than, say, on the south end where the parking lot is and craning it from there and then walking that material across the roof. It reduces the exposure of what's been installed to any potential damage and kind of reduces that risk of drop tools or drop material or something in someone's boot being walked back and forth across the roof doing that kind of traffic. Where we are on the roof, we want to protect the existing membrane. A lot of times, even roofing contractors will put down a protection material walking across finished installed roofs to provide that protection from those heavy trafficked areas by trade. And so that's just something we would highly recommend. I've seen people use old insulation boards. I've seen people use plywood. I've seen people use masonite. There's a varied amount of materials out there that can be used. The main thing is making sure you select something that isn't going to stain or damage the roof just by sitting on it over the time of the installation. Evaluate options for material staging. This is one of those things where the roof evaluation comes in handy because you don't want to overload when you're staging material on the roof, right? Everything has a live load and a dead load capacity as a structure. We don't want to make sure we're overloading those and make sure that we're spreading that load out, not only for the compressive strength of anything installed in the roof system, but the structural strength of the building itself. And we want obviously to stay in compliance with everybody legally. So make sure all those required inspections, if there's a pre-inspection, a mid-inspection, and a final inspection, making sure those are all properly scheduled and conducted. Best practices, and the nerd in me's coming out here. We can't roll for initiative or defense here on these things. We need to take our due diligence. And so we do need to trace the load path from the PV array to the structure. The PV being installed, the dead load of it, the gravitational load of it can't just stop at the roofing components. We need to understand what that load path is going to be and how it gets to the roof deck and then on into the main resistant structure. Clean and dry the roof following membrane manufacturers. A lot of manufacturers have this readily available on their website. If not, they do have it available. If the manufacturer isn't determinable, if you're going with an installed roof and you can't determine who's installed it, like I said, a roofing professional, like a roof consultant, would have typical guidelines that would be best practices to guide you on that. The big thing is making sure to have the membrane clean before the start. Cleaning the membrane also is another opportunity to identify any deficiencies in the roof before work starts to make sure those are documented and addressed and they don't come back to be blamed on the installation of the PV project as being what caused that. And finally, develop a final review of the completed project. The main thing is making sure we understand what the steps are and that, nobody walks away from the job thinking the job's finished when it's not finished in its entirety. Uh, really want to hit on the protection during construction. I've seen the deficiencies from, little bits of metal or things get stuck in people's boots and they step, drop screwdrivers, drop panels, HVAC panels, those kind of things. And we want to make sure those things are considered and try to alleviate those with protecting the roof during the install. The other thing is that while the install is going on, the roof is still doing its day-to-day job of keeping the weather out, and so its maintenance doesn't need to be neglected while the installation's going on. So, if any part of the installation is going to prevent access to a certain part of the roof, any roof maintenance plan that's in place needs to be adjusted and amended to make sure proper maintenance is still going on. We don't want to see drains blocked, or in this case, as this one shows, a basket dislodged from a drain that could create a clog and back up the drain. We want to make sure that any drainage paths aren't blocked, that scuppers aren't blocked, or gutters or drainage valleys, especially if we're on tapered systems. We want to make sure that the water can still get off the roof because we do not like seeing ponded water on the roof for any reason whatsoever. Finally, scope the responsibilities of all installation stakeholders. I had a great professor that always said 90% of all errors and issues come from communication failures. And so, if we get everybody on the same page up front, who's cutting the roof penetrations, who's responsible for sealing and flashing the penetrations appropriately, what's the timeline to cutting the penetrations to the flashing being needed, those are clearly the communication things that should be addressed up front so everybody's on the same page moving forward into the project. But in the reality of the day, we understand things happen. And so if anything's happened, if we're going to install something and it can't get installed because something wasn't on the drawing like it should have been or something like that, we just needed to have that communication as soon as possible regarding any damage or changes of the plan or potential damage. And potential damage is important. If someone drops a tool, it can be as easy as marking where that tool is on a drawing or even with a lumber crayon, so that a roofing contractor can take a look at it and see if the roof's been damaged or not, and if there's a repair necessary. So it's one of those things of it's a lot easier to tell us and it not be something than to not tell us, and then we find out it's actually leading to a leak and water intrusion into this into the roofing system.
Chadwick, we have
Yep.
a question from Jeff Spees. Can you take
Yeah,
that question real quick?
sure.
It was relating to your previous slide where you're discussing cleaning the roof in advance of doing work on it. First, like let's say TPO, what would be the common methods of cleaning roof? Is it kind of like leaf blower followed up by some kind of water cleaning? Is that a power sprayer?
Yeah, typically a leaf blower is good. It's one of those things like, you need to have a little common sense on taking assessment of what's on the roof. If you got some bigger tree limbs and stuff, a leaf blower might not be ideal because you're just blowing it off the edge of the roof kind of thing. So you want to probably physically pick up any larger pieces of debris, those kind of things. Also, if you're seeing metal pieces, better to kind of run a magnet over and pick up the metal pieces. Hopefully, it's all ferrous. Blowing metal across a roof can lead to those somersault cutting patterns that I was talking about earlier. But a leaf blower typically is utilized because doing any kind of like hand brooming or anything, again, you could push debris into the membrane and that could lead to damage as well. You asked about spraying, and I know typically one of the bigger questions is pressure washers. And I don't know of any manufacturers that have like a full-throated, like, yeah, you can use a pressure washer. Just because, especially with some of the higher pressures settings that some of this equipment has, a lot of times I think it's, a water hose, very low pressure, water pressure of any kind to kind of get the dirt off or whatnot. If the building owner is wanting to get into kind of like detergents or cleaners to make the color come back in a roof, I think anything we understand, most of these roofs on the thermoplastic side start white and kind of become a little dingy. If the building owner is hoping this becomes a bright white from cleaning, that's a conversation with the manufacturer of the membrane to identify a proper cleaning agent to utilize as part of that pre-installation cleaning.
So just maybe to clarify from what I understood you say, you probably want to avoid anything that's going to put undue pressure on the top of the membrane. So leaf blower might be okay for things that might not mar the roof, but you probably don't want to use a pressure washer to spray
Right.
down typical single plies.
Yeah, I would veer away from a pressure washer unless you've had a conversation directly with the manufacturer of the membrane and they give you some guidelines on utilizing something like that.
All right, thanks for that. Appreciate it.
Yeah, of course. Um, so we talked about damage. We can move on to the next one here. So the big question is, you have an existing roof. Is it ready for a PV system? Uh, the big thing is educating a building owner on what the expected lifespan of the system being considered and comparing that with the remaining life cycle of the installed roof system. A common rule of thumb that's prevalent in the industry is there shouldn't be more than 5 years difference between the lifespan of a PV roof and the current roof's life cycle. Um, that being said, I know a majority of PV systems are definitely 20 plus years. Um, Most new roofs can be that are installed, an overwhelming majority of them are 20-year roofs. So it's really copacetic if they're installed together as part of an overall project. That being said, an existing roof definitely can be a candidate for an installed system, but you don't want too big of a gap between the expected life cycle and when the next roof's going to be installed. For the simple fact that many times the PV systems, you can't install a new roof without taking the PV system off. And so considering that the basically an install, uninstall, reinstall cost of a PV system along with a roof is something that needs to be very, very well communicated with the building owner. Um, like I said, ideally, when we're considering these types of installations, the existing roof, more than likely, the recommendation would be to replace or restore it. Now, restoring is a charged word in the roofing industry too, because I know there's some products out there that tout that you install that product and it will extend the life of your roof X number of years. Single ply systems typically don't have a coating or a liquid component as part of their regular maintenance. Their modified systems do have configurations that do have a roof coating as part of their intended maintenance plan. And so that regular installation maintenance of that coating would be part of that life extension already of the planned life cycle. That being said, typically, if you're getting into applying a liquid product to an existing single ply roof, more than likely what you're really considering or being proposed is installing a liquid applied roofing system that should be serving as essentially a new roof. And then that takes us back to looking at all those code requirements and stuff. That being said, you do want to make those assessments and everything and get fully educated on those options before pulling the trigger on pursuing any one of those things. That sounds a little too good to be true sometimes. A PV installer should encourage that building owner to identify and review documentation for the current roof system. And the reason we put it that way to say, hey, go to the building owner for this information is typically if there's any kind of documentation, uh, for example, a warranty or a guarantee that's in place, that would be from the manufacturer typically, and that would be the contact information to start having that conversation, the building owner to have that conversation with the manufacturer about installing this PV system and what the components are and compatibility concerns and necessary details and whatnot. But it really is, it helps get the building owner more invested in the project and again does that upfront communication piece to avoid any kind of heartache or concerns at the end of a project. And so finally, we're going to move into roof performance. And the next slide, basically, I created this grid to kind of talk about the different things here. And so across the top, you have PV systems, and like we said, they can be ballasted, adhered, positively attached. On the left side, we have roof, mechanically attached, adhered, ballasted again. I said positive attached for the PV systems just so there's a little language difference while I'm talking about this chart. But essentially, as you can see, we try to do some quick pros and cons. A ballasted system, it's a quick install, both from a roof perspective and a PV perspective, but you do have to worry about movement. Um, we would probably be most strongly voiced of saying don't adhere anything to ballasted roof systems, and the primary reason is in order to adhere to a ballasted system, you're displacing the ballast of that roofing system. So essentially, you're removing the securement of the roofing system to adhere that component. You're not going to put the ballast back over that component because that would defeat the purpose of installing PV. And so we want to avoid displacing ballast of a ballasted roof if we can. Um, and then when we talk about mechanically PV, it does bypass the roof, but you do have to be worried about any displaced ballast of the roof that the ballast used for the PV also takes into account the ballast that it's taken the place of on the roof. Adhered, again, for a ballasted PV, we have quick install, but movement can occur. When they're both adhered, that's probably the most close to a BIPV, a built integrated PV component. The concern there is any future repairs to either the PV components or the roofing components can actually increase in cost because they're adhered to each other. And then with attachment, we got more roof penetrations and flashings, but again, we're bypassing the roof. When everything's mechanically attached, from a roof perspective, um, it again bypasses it, but if we try to adhere to a mechanically attached, one of the aspects of mechanically attached in some of the systems, the screws are in rows, and so between those rows of fasteners, the sheet membrane will billow. And so with an adhered system, an adhered PV system, you do have concerns about how effective those components would be if they're in a billowing kind of geometry. Um, there's no cure times with a ballasted or with a mechanically attached system, so you don't have to worry about the glue and the like you would with an adhered system, but you do have localized damage due to billowing. So again, those components, you got membrane fluttering with the wind blowing across it. So that is something to be of concern um, when we're looking at this grid of installations here. Furthermore, we're going to continue to support further research as code and regulations continue to get updated. Um, looking at uplift, fire drainage, snow accumulation, weather resistance. Um, if anything, the big thing too to talk about with these kind of installations is that PV installations, regardless of where we're at on this grid, they create more rigid traffic paths on the roof, and I've talked about this on earlier slides, but essentially, um, you're taking a wide open field, for lack of a better word, and you're creating very rigid sidewalks and roads and stuff with this installation. And so anytime that we're concentrating traffic, even if it's light roof traffic for maintenance crews, um, with increased traffic, we're going to have that increased need for sacrificial material or walkway pads, and clearly marked paths on those things so that anyone that goes on the roof understands that. So in conclusion, an understanding of that new or existing roof system is really necessary for a successful PV installation and a successful continued roof life cycle. The roof's current condition needs to be considered and different aspects of its design into account during those initial reviews. Understanding the roof system is essential to make sure we avoid any compromise of the performance. And because those kind of failures lead to very costly and operational impacts for the building owner and for the trades. And so we're going to strongly recommend that a PV standard continue to be developed to implement. I know, like I said earlier, SEIA has some standards that are in the pipeline, very close to being published. I think one's out. That's a step in the right direction, talking about best practices, service lives, and roof performance. Opportunities for us to talk like this is another one to continue that development. But we're definitely at the front edge of all the documentation and collaboration that we need to be doing to make these successful moving forward.